Okay, children. So we had derived this formula B is equals to mu naught I upon 4 pi r sine theta 1 plus sine theta 2. So now I'm going to take case 1. For a semi-infinite wire. For a semi-infinite wire, see, this is the one end is finite. One end is ending over here. One end is ending over here. And this end is extending to infinity. Now if this ends extend to infinity, so remember that theta 1 was the angle between this end and this horizontal distance. Okay, this line which was joining this point to the point P and the horizontal distance R. So the angle between this line and capital R was theta 1. Okay, now if we extend this point to infinity, so this line will keep on moving. Okay, and if this point reaches infinity, then this theta 1 will increase and increase and increase and will approximately become 90 degree. Okay, now theta 2 was the angle between this point, the other point, okay, with R. The point, the line joining this point and P with capital R. So if you see that over here, this point has come over here. So what happens? This distance theta 2, this line which is theta, which is joining this point and point P is gradually moving up with the, if this point is moved to point O, so this line will gradually move up like this and it will coincide with capital R. So what happens? The value of theta 2 becomes 0 degree. Okay, so theta 1 becomes 90 degree and theta 2 becomes 0 degree. Okay, so putting the value of theta 2 as 0 degree and theta 1 as 90 degree in this formula. Which formula? Mu naught I sine theta 1 and sine theta 2. Theta 1 is 90 and theta 2 is 0 degree. So sine 90, sine 0 degree. Now sine 90 is 1 and sine 0 is 0. So therefore B is equals to mu naught I upon 4 pi r. Okay, direction is perpendicular to the paper inwards. And how do we calculate the direction? As I've already told you, you will arrange your hand in the direction of the current and then you will go from I to R. So R is in this direction and the current is in this direction. So you will arrange your fingers like this and then you will move from I to R. So the thumb points downwards. So therefore the direction of the B will be perpendicularly downwards into the paper. Okay. Another case I am taking with you. Now this case. Now children, in this case, both the ends are extending to infinity. Both the ends. So theta 1 will be also 90 degree and theta 2 will be also 90 degree. So theta 1 and theta 2 both become 90 degree. Okay. And from equation 4, what was equation 4? This was equation 4. Mu naught I 4 pi r sine theta 1 plus sine theta 2. So in place of theta 1, I will place 90. In place of theta 2, I will place 90. So sine 90 and sine 90 is 1. Sine 90 is 1. So basically we have 1 plus 1. That is 2. So mu naught I upon 4 pi r. 2 and 2 gets cancelled over here. 2 and 4 I have divided. 4 by, we get a remainder. That is we get 2 over here in the denominator. So the equation becomes, formula becomes mu naught I upon 2 pi r. So this formula is basically a infinite length of wire, not semi-infinite, infinite length of wire. Both the ends are extended to infinity. Okay, and the direction will be perpendicular to the paper inwards. How do we calculate direction? What we do is, see, the current is in this direction, the current is in this direction and the R is in this direction. So I will rotate my fingers from the direction of current to R and the thumb points downwards. Okay, so therefore R is perpendicular, B magnetic field is perpendicularly inwards. Okay, now this case is very interesting. Case 3, for a wire of finite length. Now this wire is also a finite length. Okay, but what has happened? If you see over here, this wire was also of finite length, but one end was lying below capital R and the other end was lying above capital R. Okay, so this was theta 2 and this was theta 1. The distance, the line, theta 2 is what angle? The point, like the distance between this point and point P, and the angle theta 2 is the angle between this distance and the capital R. Okay, so what happens in this case? In this case, the lower end of the wire has been brought above the perpendicular distance capital R, has been brought above the perpendicular distance capital R. Okay, so what will happen? I will draw a line, a dotted line I have drawn, joining this point to the point P, and this angle becomes theta 2. I have drawn another line joining this point, the top point of the wire, to the point P, and this angle becomes theta 1. Okay, what I am given? I have been given this distance. I have been given this distance. The distance of the lower end of the wire, the distance joining the lower end of the wire to the point P. Okay, so this distance I have been given as R. But we always take the perpendicular distance. So I will have to find capital R over here. So if this is small r, this is theta 2. So component of R along theta will be R cos theta. Okay, so capital R becomes small r cos theta 2. Okay, so this is how we find capital R. This angle is 90 degree. The hypotenuse is R. You have to find base. Okay, so at that way also capital R will come out to be R cos theta 2. Okay, now since both of these angles theta 2 and theta 1 are in the numerator, are above capital R, so we will take both of them to be positive. We will take both of them to be positive. Okay, we will take both of them to be positive. So theta 2 and theta 1 both are positive. So now the limit has been from theta 2 to theta 1. I am reading this paragraph. Always remember, we take perpendicular distance from the wire. So capital R is R cos theta 2. Okay, now in this wire, both the ends lie up the horizontal distance. So just as I said, capital R can be called as the horizontal distance or as the perpendicular distance. It means the same. Why do we call it perpendicular distance? Because it is perpendicular to the wire. And why do we call it as horizontal distance? Because this distance is in the horizontal direction. Okay, so first thing first, that we always consider the perpendicular distance from the wire. So the perpendicular distance is capital R. So the value of capital R is small r cos theta 2. Now since both the ends lie above this horizontal distance capital R, and the angle of the lower point of the wire with point P is theta 2, and of the top point of the wire with P is theta 1, so the limit becomes from theta 2 to theta 1. So the limit becomes theta 2 to theta 1. So what I will do, I will integrate dB, that is mu naught I upon 4 pi r. I will integrate cos theta from theta 2 to theta 1. Earlier I was doing it from minus theta 2 to theta 1, but since both the angles in the are above r, so therefore I will take both of them to be positive. Okay, so now integration of cos theta is sin theta, limit theta 2 to theta 1. So what do I get? I get sin theta 1 minus sin theta 2. So earlier the formula was sin theta 1 plus sin theta 2, but now the formula has become sin theta 1 minus sin theta 2. Okay, so this is the change in the formula. So if you see this type of a geometry, then you should understand that this will be the formula, and what you can do is see the standard formula is this: B is equals to mu naught I upon 4 pi r sin theta 1 plus sin theta 2. Now theta 2 is brought up the horizontal distance r. Now since theta 2, the angle was below r, but in this case theta 2 has been brought above r. So instead of taking theta 2 as positive here, you take this theta 2 as negative. That is, let the formula be the same. Okay, let the formula be the same. Instead of theta 2 written over here, I will place the value of theta 2 as minus theta 2, because theta 2 has been brought above. From below r, it has been brought above. So instead of theta 2, I will place minus theta 2. So what will I get? What I will get? So if I place, there's a bit, okay. So what happens? The above formula is sin theta 1 plus sine theta 2. Okay, so if I place minus theta 2 in this formula, okay, so instead of a plus sign over here, it will become a minus sign. So here we will get a minus sign, that is b is equals to mu naught I upon 4 pi r sine theta 1 minus sine theta 2. Okay, so you get the same formula. So basically what you have to do is, either you learn the formula that for this kind of a geometry, when the lower end of the wire has been brought above capital R, the formula will become sine theta 1 minus sine theta 2. Okay, or what you do in this formula, in this basic formula, in place of theta 2, you place minus theta 2. So in place of minus theta 2, minus sign will come out. You will get the same formula that we have derived over here. Thank you.